So my name's Will. I work for MediaMath. We're a ad tech company, which is involved in helping like Fortune 500 companies buy digital media. So I'm trying to think like the best way to describe this. You go to a website, there's like this banner ad slot, shows up at the top, right? Everyone loves those. That actually is determined on and calculated in real time. There's an auction. We have like about 40 milliseconds to decide, do we want to partake in that auction? Do you want to actually buy that impression? And it happens about 2.5 million times a second globally. And so because of that, we have to make a lot of very quick decisions very rapidly, and we have to analyze a lot of data. So that like individual impression costs like maybe a penny or like a hundredth of a penny or so. But the campaigns that these companies are running are, I don't know, like $10 million a year, $50 million a year. And typically they accrue to like, I want to sell more of this product. And so backing that goal of like selling more of this product into, I'm going to buy this particular slot because it's like the right time to buy this ad slot, is what we're good at. It's what we do really well. So like I mentioned, 2.5 million requests per second, about 99.92% of that percentile is under 40 milliseconds. We do about 120 terabytes of data analysis every single day, and this happens across 9 different data centers, plus cloud stuff. And we do this in a lot of different languages. I think Scala might be the one that we've pushed hardest and invested hardest on in the most recent history, but we also have plenty of C++, a lot of Go, which I'll talk about in a second, Python, Ruby, Perl, PHP, and I know I'm missing more. The slide is only so long. So yeah, so talk's really about 2 things. Specifically, how does Go help MediaMath perform, and how do we make Go perform? So a little bit of both. So we'll start with the first thing. A little bit of context. In 2012, we had one giant API monolith. So everything we do has an API. Everything comes with an API. We are really big believers in like the platform vision, and our API stack, which is that kind of black box, everything below, used to be one large API, and that worked out really well for some time. But we've been going through about 60% year-over-year growth. So when I started, when TapMe was acquired back in December of 2012, I think we were about 120 people, and we're now about 650 people. And along the way, we made 6 technology acquisitions and 13 new product lines. And so I love that there was a Conway's Law talk, because I strongly believe it's like a real thing. And so we needed a way to solve for this from an organizational perspective to actually support the rapid growth that we were undergoing. I think it was said yesterday, but like I really do believe like a migration to SOA is more about an organizational solution to a technical problem than like a technical solution itself. So here we are, 2015. It's a little bit less monolithy, right? So we did a lot of the decomposition work, and we've moved a lot of things from that monolith into a little bit more of a service-oriented model, and we've got quite a number of microservices today. If you want a primer on that, I would really recommend watching Rebecca Parsons' talk from yesterday. I think that was a really solid introduction in that. And I especially, if you heard the guy in the back cackling about like what you shouldn't do, that was probably me, because we like did all of those things that you shouldn't do and have been learning. So basically, in the process of solving for those problems, we created like a whole new set of problems, right? So I love this guy because he's grumpy. I'm grumpy. So it basically turned our like already complex system, again, mentioned 9 data centers plus cloud plus all this data, already complex system into an even more complex system. It made the dependencies and the failure scenarios even more complicated and even more tricky to manage. And because of that, has created this burden on our engineers to think about these things on an even more granular basis than they had before. The yet to be decoupled services, again, like going through that transition process, you have to go through the effort of actually decoupling and decomposing things. If it's not quite there, but your teams have already done this kind of dispersion, managing that code base across multiple different teams is a giant pain in the ass. which we're, I think, still kind of trying to solve. Service discovery is now like actually a first-class problem, right? So with new services coming up and new versions coming up, and there might be 30, 40, 50. I think some of you guys are probably familiar with the Netflix chord chart of like 200, 300 different services all talking to each other. Without like that being handled in an automated way, you kind of go insane, right? I think MediaMath, actually a couple ops people in here who are living some of that pain right now. Managing environments is really painful. So we have this belief in automation that I want to test my thing against something that's real instead of just some shell. And so that means I need my thing, and I need your thing, and I need them to live in an isolated environment so I can test my thing against your thing. Without the automation to prop those two things up, what do? Right? You have to manage this all manually. That's kind of a pain. And then it introduces like a whole slew of distributed systems problems because you've just created surface area for a ton of extra inconsistency. So if you don't really focus on tools and automation, might be screwed. So my opinion, Go actually makes it pretty easy to solve some of these problems. And there's a few different reasons for that. So first one's relatively simple. It's easy to create services from scratch. Now, I know we just said that having more services kind of creates some of these problems, but as it turns out, like you can also create services specifically to solve these problems. And because it's such a simple language, there is a very low mental footprint. The first service that I wrote in Go, I think it took me maybe a weekend to both learn the language and build a proof of concept, like a meaningful one. And I think that's a very common feeling. I feel like there are a couple people nodding. Like that's something that I really kind of latched onto early on. It compiles super quickly to a static binary. So there are two parts of that are really important. One, if you have ever been spoiled by interpreted language, it's really nice to be able to hit save and like see the result really quickly. You can do that with Go. You can add a commit or a hook, right? Post-save hook on your IDE and have it rebuild the thing because it takes, I don't know, a second or two to build your binary. And then you can copy said binary from your machine to production if you wanted to, or staging if you wanted to, or whatever, because it's just a binary. There's no JVM, there's no dependencies, there's nothing. It's just a static binary. It has built-in concurrency constructs, so this is definitely not unique to the language. There are other languages that have a lot of this too, but it has Go routines and it has channels. Go routines which allow you to run functions concurrently, and channels which allow you to pass messages between them. And we'll talk a little bit about the magic in that. But that's something that kind of helps make it a little bit easier to not worry about the problem of like, how am I going to get these two Go routines or whatever to talk, or how am I going to get my concurrency to work without introducing all these failure scenarios. Instead, I can just take advantage of the language construct to solve that problem for me. And then finally, it has an awesome standard library. So the awesome standard library, when I say it's awesome, it's really awesome. In a lot of cases, if you're trying to build something from scratch, you may not actually need any third-party dependencies at all. Now, just depends on how ambitious you are, but I kind of cherry-picked a few different examples of some of the things that I use on a regular basis. So like the net package, so net HTTP and so on and so forth. It's awesome. It's actually a really good example of idiomatic Go. And there's, I think it's extremely trivial to create a HTTP server, just, on top of that. Encoding JSON, right? Tons of encoding, not just JSON, but many other formats that are baked into that system. Operating system handling, sync and sync atomic, all of your string and byte manipulation functionality, compression functionality, and the plenty of crypto packages out there are, again, really easy to create something from scratch using just what comes out of the box. But if that's not, doesn't solve your problem on its own and you don't want to be as ambitious, there's actually a relatively vibrant community currently that has spawned a lot of different libraries and tools. And those are around the use cases of service discovery and container management and configuration management, consensus and gossip algorithms and native databases and distributed caches and monitoring tools and I don't know, like 20 web frameworks, performance testing, distributed tracing, et cetera. Like a lot of those problems that you mentioned early on about like the these are the problems that I've now created by moving to a bunch of microservices. There are tools in Go and a community around solving exactly those things. Next thing is actually the tool chain is great. I could probably end on this slide. Like I could just say that this is the best thing, and then we could end and then go have beer or something. GoFumped is awesome. Like I don't know how to state this. I want this in every single language. Like GoFumped is the coolest thing ever. How many of you guys have seen this commit? Right? Obviously, I am the most productive developer in the world, and all I've done here is changed your spaces for tabs, because tabs are definitely better than spaces, and if you disagree with me, you're wrong. But what's cool about this is I never have to have this argument again, ever, because the language specification actually defines the format, and there's a tool to enforce it. Right? So we never have to talk about this. If you want spaces always, that's cool. You do that. Just at the end of your post-save hook, hit GoFumped. Done. Problem solved. It rewrites your code, has it actually line up with the specification. Now, I don't have to have this argument ever again. It's just not productive, Next, awesome tool chain tool, GoTest. So it's probably extremely common, everyone in this room, if you haven't said this, you should probably start saying this more often. At the beginning of every development project, someone goes, OK, how are we going to test this thing? Go comes with a framework baked in to solve that problem. And it comes with unit tests, and it comes with performance tests. So here's a code example that is definitely almost falling off the page. So it's really kind of stupid and basic, so kind of bear with me. I have 3 functions. 1 + 1 = 3. Awesome. 2 + 2 = 4. All right, that one's cool. And then add some ints together. Over here, I have my tests. So 1 + 1 actually should be 2. Cool. And then 4 + 3 + 2 + 1 should be 10. Awesome. So I'm going to run my baked-in tests, and I get, with a coverage profile. So obviously, 1 + 1 should actually be 2. So that's my failure message. And I missed that second function, 2 + 2. I didn't do that. So coverage, missed the coverage. And then if I actually go to the Go tool that helps me dump an HTML file that shows me these things, it will show me the code path colored that's not covered. That's kind of nifty. Next awesome tool chain is the race detector. So mentioned some of those concurrency constructs. Those are really nifty, but if you're not careful, you can actually create deadlocks and race conditions. And the race flag is available in Go test, Go build, Go run. And it will just cause a panic when it detects that there's a race condition. Do this, please, in your code. If you use these things, it's really important to do this. And then finally, GoVet. GoVet is, it's interesting because it's like a heuristic that helps show, it tells you when you may have used something wrong, right? So if you have like a JSON tag and you use it incorrectly, or if you have printf and you have mismatched placeholders, like it will tell you those things that the compiler won't already catch. And actually, the compiler catches so many things that this is just kind of a nice add-on. So I don't know, like for me, where this kind of all boils down to is it just feels really productive, right? The language gets out of the way. And for me, maybe, it's just a personal thing. I know there are people from MediaMath in this room which would disagree with this, and that's totally cool. But I like the constraints. I don't mind constraints. The constraints plus the tools make me feel more productive. And it lets me focus on the thing that I actually care the most about, which is shipping a good product. And we have, right? So in 2013, we had no Go things. And in 2015, we have like infinitely more Go things. So if you wanted to draw this line out, it would have looked a lot like a hockey stick. And if there are any VC in the room, I'm definitely taking checks, because traction. So how fast is Go actually? This is like my favorite part of this talk, because I'm going to try to piss everybody off in the room equally. I have cherry-picked in the next 4 slides a bunch of benchmarks that show how Go is faster than your favorite language. Actually, some of our favorite languages. Doesn't really prove anything other than I can Google things. So yeah. All right, so Go versus C++. It's like about as fast. I think some here bolded. It's faster than C++. That's cool. The rest, I think it's like order of magnitude the same. Yeah, awesome. All right. Oh, cool. Ruby. Yeah, we love Ruby. We're huge users of Ruby. Just destroys Ruby. I mean, take a look at that. 16 versus 799. Man, I don't even know what those numbers are, but it's a lot different. Go versus Perl. So we really love Perl. Like, we love Perl so much, we go to Perl conferences, we give Perl talks. We're actually going to YAPC this year to talk about how we're moving from Perl to Go. So that may be a little weird, but also like substantially faster. OK, so I'm at a Java conference, so I have to talk about Java, or at least there feels like there's a lot of Java here. I really hope that like Giltine and anyone from Oracle is not in the room, because don't call me out on this. But as you can see, Go is also order of magnitude as fast or slightly faster than Java. Awesome. And Node. Yeah, Node. This is my favorite meaningless benchmark because it is a clear and obvious representation of real work that's done in Node, which is otherwise known as bubble sort. So yeah. Just as a side note, Ryan Dahl, who built Node, and TJ Holloway-Chuck, who built everything else in Node, both switched to Go. So just saying. But seriously, though, Go is actually pretty fast. As I mentioned, we have like a 21, 23-ish services in it. Here are a few that I kind of cherry-picked for this talk. DCS is the Dynamic Creative Service. It's like this thing that takes add requests and automatically generates the creative together. And we've landed on 95th% latency, under 10 milliseconds on 2 boxes per data center, handling live bidder traffic. This is really, really good, because it's cheap to run. Roller Skates is this, it's like a one tiny VM per pop that's handling all production impression metrics on 5 dimensions rolled up in 3 different time buckets, I guess. Super cheap. Auth-Go handles all of the traffic for this thing. It's the authorization service. 1 millisecond, 95th percentile, 2 boxes per pop. Just trivial. Plex is actually it's a multiplexer, web request multiplexer, currently doing a little over 100,000 requests inbounds per node, and it's almost completely kernel bound. All with extremely little effort. None of these projects took, I think, like the base took a week, 2 weeks to build. And I think the reason this matters, both from a productivity perspective and a performance perspective, is that any response in your distributed system across your microservices that's cobbled together from multiple different services, it's only as fast as your slowest link, right? So here's a request that took 112 milliseconds. 94 milliseconds of that was spent in this one function. You got to make sure that your critical path is fast, right? If it's not, whole thing's gonna be slow. And this is common, right? By the way, this tool is called Zipkin. If you're not familiar with it, it's Twitter's distributed tracing framework. If you want to get it, crap, now I'm forgetting the name of the tool. Anyway, it's possible to get your Go data into Zipkin as well. All right, so we've talked a lot about how Go is the fastest thing on Earth. How do we get it there? Pretty simple. Well, so the first one is Go test and testing B. So I talked about how Go test has performance testing. Testing B is that thing. It does loop-based iterative performance tests, and it's baked into Go test. So you can actually run these performance tests as part of your test suite, as part of your pre-commit lifecycle, as part of integration tests, as part of whatever stage of testing that you want to introduce it in. Here's an example of me running this Fibonacci function B n times, which is part of the testing B. And it took 509 nanoseconds per op. Cool. Next awesome tool, also part of the tool chain, pprof. So thank you, Google, for this. pprof is a sampling profiler. Comes with visualization, which you're seeing right now. and also a fair amount of command line tools. I've actually spent more time in the command line tools than I have in this pretty graph. Also useful, though. It tells you basically how much time is being spent in what part of your code. It can also tell you where you're allocating, which is important for garbage collection. And it's just generally very useful for understanding what your code is actually doing, right? So use this if you want to understand where your hot code paths are or where you're spending most of your time, user time, and that way you have to guess less. That's cool. Go is a garbage collected language. It's young, right? It's not as old as Java. Has a lot to learn from Java and from the JVM in that sense, but it's still garbage collected, and the garbage collection isn't quite great yet. So avoid creating garbage if you don't want to deal with garbage collection. Definitely do this after your code is written, right? Don't do it early, otherwise premature optimization, that sort of thing. But the previous slide, pprof, it will tell you those allocations. It will tell you where the GC is coming from. You can definitely use it to tune away some of the unnecessary allocations if there are some. The other great thing is that Go has a 6-month release cycle, and they spend a lot of time focusing on performance and toolchain and garbage collection. I believe 1.5 is going to introduce concurrent collection, so like the really heavy stop the world collection will be, I think, a little bit less impactful. We yet to actually see that played out, but hopefully it's there. OK. Go Max Procs. So we talked a little about Go routines and channels and how there are concurrency primitives baked in the language. But what about parallelism? Go Max Procs is a setting that basically lets you tune the number of operating system threads your code runs on. So initially, you go, oh, cool, set that to 8 or 16 or 32 or how many physical CPUs your box has, cores your box has. But in many cases, all that does is increases contention. Test before you set. Don't just run blind. Thing that I randomly ran into the other day was setting Go Max Procs to 1 doesn't actually stop the operating system from running across multiple cores. That makes sense, but I was a little confused why I was paging everything randomly. It's possible. OK, next thing, channels like magic. So I think I've talked a little about channels and Go routines. Haven't actually showed you guys an example of this. So this is an example of both. This is my main function. It's a really dumb function. So echo is a function that basically takes a channel, listens on the channel. Whenever it receives a string on the channel, echoes the channel, or the string. So over here, I'm creating that as a Go routine, which is effectively saying, run this function concurrently. And then I'm sending on the channel these messages. So these messages are just strings, hence the chan string. It's the type of the channel. And so I'm sending it, waiting a second, sending it, waiting a second. This is all it is. It's an awesome construct. It's really handy. But unfortunately, it's not actually magic. There's still a Mutex Lock. So just consider that every time you use it. Again, if you tune up Go Max Procs, you're just, in some cases, you might not even realize that you're increasing contention because more things will be contending on that lock. Yeah. All right. So empty interfaces. So empty interfaces are interfaces without methods, which is kind of another way of saying match against all types. Any, sure. If your function argument specifies an empty interface, then it will accept any type, and that's at the expense of performance, right? So here's an example of sum everything of any type. Here's an example of sum just ints. And because runtime type checking is slow, you get this ridiculous difference here. I don't know what it is, like 60 times as slow. Again, don't really worry about this until after your code's done. Yeah. Defer, super convenient. So this is a keyword that effectively lets you say, I'm going to close these file buffers or allocators or channels or whatever when I'm done with the function. I don't have to worry about doing it manually. If I didn't do this, I have to put it in all these different places where error handling is done here and maybe at the end of the function and so on and so forth. I don't have to do that now. I can just do it when or rather, I can let Go decide when to do it based on the unwinding of the stack. Of course, this is also slow because now what I'm doing is I'm telling Go to keep track of another thing to unwind as part of the stack. So I think this is telling, but maybe in the case of your application, this might be more telling, 18 megabytes per second versus 6 megabytes per second of throughput. Again, it just depends on what you're doing. And then finally, GCC Go. So Go is not only an implementation of language, it is also a specification of language. So they have targeted the compilation of the language also against GCC. So you can build Go code with GCC. And this is good because it gets you support for some of those more powerful optimizations, O3 and whatever you get out of GCC. Could be good for CPU-bound workloads. You might want to use this. We tried it. We didn't get a lot out of it, and we actually also wasted a fair amount of time trying to figure out why. So I don't know, might be good for you. I wouldn't run there. I would start with the code. But if you're wondering if can I get just that last 1% or 2%, might be worth trying. OK, so I'd be remiss to talk about this without actually talking about some of the things we don't like about Go. I personally am OK with some of these things, but I know that us, like MediaMath as a whole, some of us struggle with these things, and that's totally cool. I think no language is perfect, obviously. So the first thing that I think rubs a lot of people the wrong way is it's extremely opinionated. I think the quote that I've read a million times over is like it seems to ignore completely the last 20 years of computer science. OK, cool, I get it, I understand. And specifically, the two, really the one that comes up is the limited type system, which is, I think, just another way of saying no generics. So that's kind of a pain. Yeah, we'll just leave it there. Also doesn't have exceptions. So the way that the idiomatic way of handling errors is effectively multiple return statements. So your return will have the first or the second, whatever. The first few arguments will be what you actually expect. The last one will be the error case. You can do that in Go. It's very common. And you have panic too, but I think a lot of people probably prefer exception handling and catching and throwing and so on and so forth. Third thing I think that gets people a lot is this notion of idiomatic Go. It's basically the idea that all Go code should be articulate yet concise, provide precise comments, have a simple API, and be readable. I know none of that is controversial in any way. And the standard library is actually a great source of truth for what is idiomatic Go. But the problem with this notion that I have is it's very subjective. And so because it's so easy for people to grasp the language and just go running with it, it has created some extremely interesting pull request conversation in our company where you have 50 comments of existential arguments over whether this is the right way to do things or what's idiomatic or what did the Go developers really mean when they said that. And yeah, I struggle with that one because I completely understand why you would want to do it, and I also don't know necessarily the best way to lead a new Go developer to the answer other than read and practice and look at the Go source. It's not, super fancy. Dependency management. So Go being developed primarily at Google, those guys have their own massive dependency management solution and have almost deferred dependency management to the community. I think I've read maybe 4 or 5 comments by Andrew Gerard and Rob Pike and Co. basically saying that's a community problem, you guys can solve it for yourself. But what that really means is the import statements I think you guys may have seen in some of the comments or some of the code examples earlier. You have no way of saying a package is pinned to this particular commit, and that's a pain because in order to pin it to a particular commit, you have to ensure that you have that commit in your local GoPath, which is just another way of saying vendoring is the best way to do things. And if that feels like we've gone back to 90s, it probably is because we've gone back to 90s. So I think a very, very known issue. And then finally, garbage collection. Yeah, it is what it is, right? So if you need more granular control over your performance, over your latency, maybe don't use Go. I don't know. I don't need access to machine primitives. We do all this at incredible scale, and we still seem to be doing OK by just using the mechanisms and methods that I mentioned before. But just something to be aware of. Again, Java's a GC language as well, so I think we probably all feel this pain in some way or another. I think that's it for me. I'd love to take questions. Hope this was helpful. Oh, and we're hiring.